In this training module, we will be discussing respiratory systems, specifically Grade D respiratory air and Type C and CE airline respirators. OSHA stands for Occupational Safety and Health Administration. OSHA does not approve safety products. It is the federal body that establishes guidelines and regulations for worker safety. The OSHA CFR 29-1910-134 speaks to breathing air compressors and references the quality of air needed to be supplied to respiratory devices. The Compressed Gas Association G7.1 1989 standard defines the quality of grade D and E breathing air. NIOSH stands for the National Institute of Safety and Health. It is a federal organization approving respiratory devices to include respirator hose and face pieces. The NIOSH 87-116 document on page 65 establishes the point of attachment criteria for respiratory devices. NIOSH defines the POA as the point at which the respirator hose attaches to the grade D compressed air source. At that point, four things must be present. 1. Air pressure regulator. 2. Pressure gauge. 3. Safety relief valve, preset at 125 psig. And 4. The respirator coupling compatibility. All respirators are classified as either negative pressure or positive pressure respirators. To understand breathing air, you must first understand the various types of NIOSH-approved respirators available to meet the respiratory hazard. When wearing a negative pressure disposable respirator, the wearer must inhale through the mask. These are approved for nuisance dusts, mist, vapors, and fumes. Negative pressure cartridge respirators have replaceable cartridges and come in half mask or full face. Powered air purifying respirators provide filtered air to the worker. Make sure the appropriate cartridge is being used for the contaminant the worker is being exposed to. These are not approved for immediately dangerous to life and health situations and are commonly known as IDLH. Here's a tip. Masks must be fit tested to assure a good face seal. Let's begin with the elements of a Type C system for grade D air. A Type C system is any respirator requiring a hose connected to a compressed air source. Positive pressure respirators are used in Type C and Type CE systems requiring grade D air. Let's break down what those look like. Type C breathing air system will include these four components. Number 1, compressed air source. Number 2, filtration. Number 3 would be the air distribution, and number 4 is the respirator. Stationary Type C breathing air systems are ideal for applications where portability is not needed, such as plant air systems when a large number of workers are using respiratory protection requiring a large quantity of grade D breathing air. These systems are available in up to 3,000 cubic feet per minute, or commonly called 3,000 CFM. The compressed air source can be a mobile compressor, a fixed plant air compressor, or air cylinders. The filtration element of the Type C breathing air system creates grade D breathable air with carbon monoxide monitoring as defined by OSHA 1910-134, CGAG 7.1 in the USA, and Z180.1 in Canada. Once we've compressed, filtered, and monitored the air, it needs to be distributed to the workers. Air distribution is done by point of attachment devices, POAs. The point of attachment per NIOSH regulation is a point of attachment must have the following. 1. Air pressure regulator. 2. Pressure gauge. 3. Safety relief valve preset at 125 psig. 4. The respirator coupling compatibility. The positive pressure airline respirator constant flow mask provides better protection than air purifying negative pressure respirators. The constant flow respirators supply air continuously to maintain a positive pressure inside the facepiece. This style is available in half mask or full face and requires 4 to 15 CFM airflow per mask. Fit testing of the mask is required. Positive pressure demand style airline respirators supply air on demand and maintain a minimum positive pressure in the facepiece at all times. They require 4 to 15 CFM flow to the mask just like a constant flow style respirator. Pressure demand respirators provide a high protection factor and can be used on cylindered air or filtration systems. Note, when used with 5-minute HIP bottle, it allows for use in ideal H atmospheres. The mask fit test is required. When cylinder air is your compressed air source, the air quality in that cylinder needs to be grade E quality air. The main difference between grade D and grade E quality air is the moisture content. Grade E air is very, very dry to prevent moisture from accumulating in the storage cylinder. Moisture in a cylinder will cause corrosion inside that cylinder. Grade D air is not as dry and should not be used in cylinders. Positive pressure airline respirator constant flow hood style are classified by NIOSH as Type C or Type CE. Shown as a Type C. Hood style airline respirators require 6 to 15 CFM airflow per person. No fit test is required with the hood style respirator. The difference between Type C and Type CE air is the respirator being used. A Type CE hood is a special category of Type C respirators. Type CE hoods are used in the sandblasting, paint, and coatings industries. The compressed air typically used in Type C air is supplied by a large stationary plant air system or a portable high-capacity compressor. Grade D filtration for the Type CE respirator will be similar to that of a Type C system. However, larger capacities of airflow will be needed for the increased air needs. The POA is the same for a Type C and Type CE air system. POAs may include cooling functions such as the cool box. The Type CE breathing air system uses a constant flow hooded respiratory device. This is unique because it has a protective head covering and an extra long, heavy bib to protect the worker from shot blast injuries. There are many things to consider when sizing a system. What type of respirator is being used? Is it constant flow or pressure demand? If it's constant flow, is it full face, half mask, or hood? Will a vortex cooling or heating tube be used? Will a cooling vest be used? Under the pressure demand, how many workers will be wearing each of the above? What job function will be performed? Where will the job be performed? Is it in the field? In a plant? Is it ideal H? Once you have answered these questions, it will guide you into selecting the correct product for your client. Our customer service reps are trained in assisting you to select the proper system. So if you have questions, please use this available resource. We will be expanding into sizing a system during our product training classes held at our headquarters.